When you're simplifying radicals, there are a few rules that you need to follow. One is we never want radicals in the denominator. So whatever way it's going to take to get that radical outside the denominator, that's what you're going to do. So let's say we have an example where we have 1 over the square root of 3. I need that radical to go away. It can be on the top, that's fine. It just can't be in the denominator. And since a square root is looking for something to be squared, we're going to square it. We're going to do exactly what it wants. And so we're going to do it on the top and the bottom. And so what we get on top is the square root of 3 over 3. Or if you want this written out as an additional step, we can also say the square root of 3 over the square root of 3 squared. Notice that we have a square and a square root, so they go away, and we get the answer that we already looked at, which was the square root of 3 over 3. So that's the first thing that we want to always maintain. Let's look at one more example, just so we kind of take a look and see what's going on. Let's say we had 2 over the cube root of 7xy. Now, again, I have the situation on the bottom. It's not great. I need to get it out from the bottom. I have a cube root this time, which means the thing I want to do is to get a cube. So what I'm going to do is I am going to do 7xy, and I'm going to write this out really explicitly, so I'm going to do another 7xy, and these are all cube roots because I'm sticking with the same system, right? So on the top, that means we're going to do the same thing, the cube root of 7xy times the cube root of 7xy. You can also have written this as, I'm going to rewrite the first part, as the cube root of 7xy squared. They're both the same thing. It just kind of depends on what you prefer, right? So your call. Now, what happens when we do this on the bottom is, notice now we have a cube root of 7xy cubed, right? Because there's 3 of them. On the top, we have 2 times the cube root of 7xy squared. And so let's just simplify this a little bit and put a nice little squiggle. So on the top, we have 2 times the cube root of 7 squared is 49. X squared is x squared, and y squared, same thing. And on the bottom, that cube root and that cube are going to cancel out. And so I'm going to end up with 7xy on the bottom. Okay, so that's kind of what we're trying to do, is simplify our situation. And this helps us clean up. You could theoretically go a little further. You would end up with exponents with fractions. So if your professor is comfortable with where we are now, pause here. Otherwise, you can kind of go a little further. I'm going to pause right there just so we have an example. And we're going to do one more type of radical simplification, and that's when we can cancel out stuff. So basically what I want to do is I want things to get as simple as possible. So let's say I had the square root of 18 over the square root of 2. Okay, so I'm going to use a rule that says I can break up my radical, and I'm going to do a factor of it. So 18 has the factors of 9 and 2. So I'm going to square root of 9, square root of 2. And on the bottom, I just have my square root of 2. And the square root of 9 is a perfect square, and it's actually 3. So then I have 3 square root of 2 over square root of 2. And because I have square root of 2 on both the denominator and the numerator, and they are the same value and multiplying, I can cross it off, which leaves me with just 3. So that's kind of what I'm looking for. So all I'm trying to do is simplify it. Sometimes it won't be so pretty and you'll end up with a square root anyway or a cube root, and that's okay too. So let's say we had a different one, something less clean. Let's say we had 20 over the square root of 4. Okay? And so in this case, I'm going to break up the top and the bottom. The square root of 20 is going to be broken down into the square root of 4 and the square root of 5 because they're the factors. And we have the square root of 4 on the bottom. Now, you could actually solve for the square root of 4. It's a perfect square. Or you can notice that there are square root of 4 on the top and the bottom, and they cancel, which leaves us with just the square root of 5. So whichever way you go, all you're going to do is find the factors, simplify it down, and cancel out the ones that are the same. That is what you're looking for.